Okay, combining permutations. We have a question where they're talking about the word Toronto. Okay, how many permutations can you get with these three stipulations? So the first one being with one T in the front always. Okay, so essentially we could try to write this out and we'll do one step at a time. So we'll call this A. Option A. Well, we have the word Toronto, T-O-R-O-N-T-O. Okay. What we're going to do is the very first one, we're going to pin T at the beginning. Okay. Think of it as a cinder block. It cannot move. So essentially, it takes itself out of the running. Okay. So the only options left are, we really only have this many numbers to work with. 1, 2, 3, 4, 5, 6. We have 6 numbers to work with. They can be rearranged any single way. So in our first example of A, if T is pinned down in the middle, we have permutation 6 to solve that one, right? Mm-hmm. But because there are 2 T's in this option, we could also take it, even though it would give you result in the exact same thing, unless they want it to be distinguishable, we could also pin the other T. So the way I'm going to separate these T's is uppercase T and lowercase t. Okay? So let's say, well, I put lowercase t in the front and made that the anchor. Well, if that's the anchor, now I have O-R-O-N uppercase T-O. Still Toronto, right? Again, this guy's pinned down. We still have 6 letters to work with. 1, 2, 3, 4, 5, 6. And that's permutation 6, again. So technically for the first one, we would be taking permutation 6 plus permutation 6. But, okay, in this question, I'm not sure what the person was looking for. Technically, these will be identical. Remember, we just went over those? Those will be identical. So really, the true answer of distinguishable answers is just permutation 6. But if they want all options, and in other words, listing, uppercase and lowercase t as 2 different letters, then we'd have to add the 2 options together. You know what? In this one, we'll go with, well, we'll do them both. We'll show you how there's 2 different answers. So that would be our A. For B, exact same idea, with 1 T in the back always. Okay, well, that's, I'll call our question B. Well, let's put the uppercase T at the back. So we have O-R-O-N-T-O uppercase T. Okay, well, again, that guy gets pinned down. Let's scroll down a little. That guy gets pinned down. And how many permutations do we get here?
6.
Yeah, exactly. We still got 6 letters to work with. So this gives us permutation 6. And their other option is O-R-O-N uppercase T-O lowercase t pinned at the back. Exact same option as above, right? No difference here, permutation 6 again. So part B, again, is even though they're exactly redundant, they're the same 2, just one being uppercase and one being lowercase, we'd be adding those permutations together. Now, the hard part of this question is C, with both T's side by side, okay? Well, that means they can be anywhere in here. But what it does mean is we're also anchoring ourselves. So we're going to add up many small permutations instead. We're going to anchor ourselves at the very beginning of this one. So here's C. And we're going to put uppercase T and lowercase t at the beginning. Okay? Well, that leaves us with the letters O-R-O-N-O. That's 1 permutation. So that's 1, 2, 3, 4, 5 letters. Okay? So that's permutation 5. Now, technically, there's also this exact same order with lowercase t being first, uppercase t being second. They're still side by side, and we still have O-R-O-N-O. Okay, again, 1, 2, 3, 4, 5 letters. Permutation 5. Okay, they didn't say whether that's considered opposite or not. Even though they'd be redundant, they don't say anything. Okay, but we're not done there. There's many other options across here. For instance, we end up with many different options to the point where it becomes so many answers because we can slide the 2 T's to be 1 letter over. And with each of those letters, there's many different options in it. So this question becomes very complex because let's say, and what we'll do is we'll just focus on the left side, uppercase T first, lowercase second, and we'll just pretend that the second ones are redundancies. Well, I also have the option of O being in front and T being the second letters. Okay, let's say we pin the other O here. Okay, still T and T are beside each other, and we'll say we use this O. Well, then we're left with O-R-O-N-O. Okay, again, we could switch it with the uppercase. So that's 1, 2, 3, 4. This is permutation 4. So right now we're adding these two permutations down. Think like we're going vertically, okay? So I have this option plus I have this option. Then obviously I have the redundancy where I have lowercase t and then uppercase t. But I'm going to stop writing redundancies because I think the way to truly solve this question is we actually kind of want to get rid of all of our redundancies, okay? We also get the option here. See, all of these O's, if I put them to the front, they create the same thing, okay? So I can put the other O in the front, the other R in the front, and the N in the front. So we're looking at 1, 2, 3, 4 options of permutation 4. So what I mean by that is we call this O1. Let's call this guy O2. Well, I could put O2 here with my two T's. They all get pinned down together, and I'm left with O1, R, N, O. Well, that's 4 permutations. Or I could have O3 with the two T's, and have O1, O2, R, and N. Again, 4 permutations. We'd be adding those together. And then we could have R in the front with the two T's. Okay, those all pinned together. And then we're left with the 3 O's and an N. That's permutation 4. Or we could have N in the front with the two T's. And we would have the 3 O's and an R. That's permutation 4. Okay? Well, you'll notice as we go through this, there's many, many options like this. And we're going to get into a lot of answers here. So what we have to kind of figure out is how many different versions or how many different spots can the T really go through, okay, the sets of T together. So almost think of them as, we want to think of the T's almost as a letter in themselves, okay, because they're always going to be pinned together and it's just going to be moved around, okay. So if we were to do it this way, it becomes almost too tedious, right, with all of our redundancies. So if we were to think of the T as a letter in itself, so let's say let TT just equal just letter T, okay? Well, now let's just put that together. Well, now we have T-O-R-O-N. There's normally a T here and O. Well, now how many letters do we have altogether?
6.
1, 2, 3, 4, 5, 6. I have 6, and this T, there's no restriction on whether it being first, second, third, fourth. It doesn't really matter. So now I'm stuck at permutation 6 for this. So I have 6 options of when the T's are side by side. Even though in Toronto there's technically 7 letters, right? If they were to just ask us for Toronto in general, do I have another color? Yeah, black. If they were to ask us for T-O-R-O-N-T-O with no restrictions, that would be permutation 7. But we decided to put the 2 letters together, so we just represent it as 1 letter. So it's permutation 6, okay? Let alone that we could also have let lowercase t, uppercase T equal big T, and then that would be permutation 6 again. Does that idea make sense?
Mm-hmm.
So essentially, in the end, our third option is, again, permutation 6 plus, and then if we were to flip the order of the 2 T's, permutation 6. Now, we don't know if they're trying to get rid of redundancies, and we didn't do it with getting rid of redundancies, right? So what we're going to say is we would essentially add all of these together. So your true answer here is 1, 2, 3, 4, 5, 6 versions of this. So in other words, this plus this 6 times, okay? Or it could be written as 6 times permutation 6, okay? That's without eliminating redundancies. If we were to eliminate redundancies, then it's a different type question, right? Because then we start getting into, well, this is not just permutation 6, there's the redundancy of our 3 O's. So it's permutation 6 divided by permutation 3, right? And then same with this question here, same with this question here, and then tactically when we get down to this one, it even becomes a little more complex because, well, actually no, it's the same thing. It becomes divided by permutation 3. So depending what the person's asking. So without redundancies, this is our option. I don't even know if we can get it on a calculator. Let me see if I can actually figure it out here. If my calculator will take that number. Permutation 6 times 6. We're looking at 4,320 options without eliminating redundancies. Okay? Does that make sense?
Yeah.
Do you want me to do it with the redundancies, or do you think you got it?
I think I got it.
You think you got it?